In this lesson, we're going to review systems of inequalities. We've previously looked at linear inequalities. Now we'll be looking at functions of higher degree. In number 11, we're going to graph a system of quadratic inequalities. So looking at the top inequality, I know it's a parabola that opens downward, and I'm going to find the vertex. I know that it's been shifted up vertically 4 units and reflected downwards. The vertex is going to be 0, 4. There's an ordered pair at 1, 3, and another ordered pair at 2, 0. You can quickly find that using your graphing calculator. By symmetry, there would be another point at negative 1, 3, and a point at negative 2, 0. Because it is less than or equal to, I know that this is going to be a solid curve. I'll shade momentarily. For my second inequality, the one highlighted in green, I'm going to find my vertex, which if algebraically I do negative b over 2 times a, that would be positive 2 over 2 times 1, which is 1, and if I substitute 1 in, I get negative 4. I know it's going to open upward because my a value is positive, so I'm going to find some points to the right. I see one at 2, negative 3. By symmetry, there would be one at 0, negative 3. I'm going to find one more. There's a value at 3, 0, and negative 1, 0. This would be a dotted curve because it is greater than, not greater than or equal to. So let's consider where we're shading. The first symbol is less than or equal to, so we would be shading below the red curve. And the second one is above the green curve. So below the red and above the green would be this overlapped region in here. Now we are going to state 3 possible solutions. So any ordered pair in the shaded region, such as 0, 2, 1, 1, 1, negative 3. These are 3 possible solutions to this system. In number 12, we're looking at an absolute value function and a quadratic function. The top one would have a vertex at negative 4, 0, when we say opposite same. And the slope of the right ray is negative 1. It would also be a dotted absolute value function. So it's going to look like this. The second one is quadratic. It's going to be a parabola. So I'm going to draw this one in red. The vertex here would be negative 4, negative 4. It will open upward, and I'm going to find another point. There's an ordered pair at negative 3. Negative 3, you can certainly put that in your graphing calculator or substitute in negative 3 into the function to see. And I just realized I have a correction to make. I didn't realize when I looked at this quickly that that's actually less than or equal to, so I need to go back and make this a solid V, no dotted line here. Whereas the parabola will be dotted. And now we're going to be shading above the red and below the black. So that overlapped region would be this region here between. So name 3 solutions. I'm going to say negative 4, 0, because that is on a solid part in surrounding the shaded region. Negative 5, negative 2 is another. That's right here. And I'm going to go with negative 3, negative 2 as a third possible solution. Remember that there are decimals as well, so like negative 3 comma negative 2.1 looks like 1. But nothing on this curved part of the parabola would be a solution because this is dotted. This part is solid, so solutions would fall on this area. The intersection of the two would not be a solution because one's dotted. They both have to be solid for it to be a solution. Perhaps you can try 13 on your own. Pause the video, press play when you're ready to check your answer. So the first equation is linear. Y is less than or equal to 3 would be a horizontal line fixed at 3. The second one is quadratic. I will graph that in yellow. Parabola with intercepts at +1 and -3, which means my vertex is halfway between at -1. And if I substitute that in, I get -4. This would be a solid curve. Oh, forgive me. I'm drawing dotted but said solid. It is dotted because it's greater than. So when I think about shading, I'm going to be below the first, above the yellow second, and the third is a cubic function. It's the parent function crosses at 0, 0. Looks something like this. And it will be below this one. So, below the red and blue, but above the yellow, will be this region in here. So, we need to name 3 ordered pairs, and they need to be in that shaded region. They do not need to be, or they cannot be on one of the curves, so it looks like -1, -2. 0, -1, and 0, -2.